Yep. Recording. Can you see the share screen? Yes. Can see.
Yeah.
Can hear me as well. Very good. Okay, carry on. So now our formula. The purpose of this fancy formula here is for you to solve a certain type of trigo equation, practically speaking. So let's say, for example, if I start you off with square root 3 sine theta minus cosine theta equals to 0. Can you solve this equation? Definitely, right? How would you do it?
Plus cosine theta, then divided by sine theta, which would just be cotangent theta.
Wow, that's a bad choice. You divide by sine. What's a better choice? More direct. Instead of sine, how about if we divide by the other guy?
Cosine.
Then you don't need cotangent. Straight away you can get sine theta over cosine theta. Right hand side is cosine theta over cosine theta, which is just a 1. And that sine over cosine is tangent, right? So square root 3 times tangent. So tangent theta is equals to 1 over square root 3. Agree? Then what's your alpha? Tangent inverse. I think this is 30 degrees. Let's just stick to 0 less than x less than 360 degrees. Maybe I'll include. Yeah, so then after that, what is theta? This is a positive value. So ASTC tells me it must be over here or here, quadrant 1 or quadrant 3. So therefore, theta must be quadrant 1, 30 degrees, Q1, or theta must be in 180 degrees minus 30 degrees. That's not correct, it should be plus, because it's Q3. 200 then. Okay, easy, right? Don't need R formula. Don't need R formula. But now I'm just going to make a slight change, and now you will need R formula. I hope you can see the key pattern here. This, wait. Let me finish writing before talking. Need R formula. Then I make a modification. On the right hand side, I just change it into a 7. Can we still do the same trick? Bring the cosine over, divide by cosine on both sides, and get a tangent, get a constant, and number bring over. Can we still do it? Let's just try.
Okay.
Just now, what do we do? You see, the left-hand side looks exactly the same. So why don't we do the same procedure? Minus cosine theta, bring over, right? Then what do we get? Let's explore. We get 7 plus cosine theta. Then we want tangent, right? So what do? We divide by cosine, right? So sine theta divided by cosine theta. Then here, unfortunately, the entire right-hand side needs to be divided by cosine theta, which ends up being 7 over cosine plus cosine over cosine, which is 1. Which is like 7 times secant theta plus 1. And sine over cosine here is just tangent, so square root 3 times tangent theta equals to 7 secant theta plus 1. Do you see the problem here? Before, after. What's the extra thing? Extra thing.
I don't know. Wait.
Yeah, the 7, which led to us extra 7 secant theta. This 7 secant theta is very troublesome because now the theta is in 2 different places. Can you see? 2 different places. Then we cannot solve it easily anymore. So far, I've only taught you how to solve trigo equations when there is only one single unknown argument. Here, the argument appears. There's one single, as in the argument only appears inside one trigo function. Here, the theta argument that you're trying to solve for is appearing in 2 different places. So definitely we cannot solve this so simply. Okay. Also, the purpose of R formula is for us to convert this fellow over here on the left-hand side into a certain format. So it could be R sine theta plus alpha, could be minus alpha as well. Or it could even be R cosine theta plus alpha, or R cosine theta minus alpha. Okay, these are the 4 formats that you need to convert it into, right?
Yes.
And here's how we do it. So this is impossible to solve. Okay, here's the question, here's the answer. Impossible to solve, exclamation mark. And hence we have to deal with this question, but using special R identity formula. So let's just go through how that formula works. So the question will usually give you the requested format that they want you to use it in. And usually if you see sine here and then cosine or minus in between, it will probably be this fella over here. Can you see that they look very similar? Right? Almost the same. Right? It's like the angle A is theta. Then the rest of the things that are multiplied by sine A, multiplied by cosine A, those will be your ratio. I mean, those will be your coefficient. Okay? And you try to match up. If you see minus, you match up with a minus. Sorry, over here, minus. So that we can always make sure when we try to find our alpha angle, it will become positive. Let me just demonstrate it, not in general, but for this specific example. Okay, so what we're gonna do is we're gonna say let square root 3 sine theta minus cosine theta. Okay, maybe just to be more specific, I'll put an extra 1 in front of the cosine. Oh, let it equal to r sine theta minus alpha. Why do I want to do that? Because if I expand the right-hand side, what do I get? R is multiplied by sine theta minus alpha. Just expand. What do I get? Sine theta cos alpha. And tell me the rest. I will wait for you. Mic test, I cannot hear you. Can you hear me?
Yeah. Sine
Okay.
theta cos alpha. Then cosine alpha. Wait, cosine theta sine alpha.
What sign is in between? Plus or minus?
Minus.
Okay. Very good. Then you just multiply the r inside. So you end up with r sine theta cosine alpha, right? Minus r cos theta sine alpha. Now this, I don't like it when my r and the alpha are far apart. So I just swap them around. R times sine theta times cosine alpha. I rewrite it as r cos alpha times sine theta minus r sine alpha times cos theta. Is that okay with you? Clear so far?
Yeah.
Okay. So now why do I want to do that? It's because I can now compare coefficients, exactly what you did, right? So CF compare like terms. CF means confer. It's just a fancy way of saying compare, but it's formal. You can use it in official report writing. CF. And it's also shorter to write. Yeah, so CF coefficients, and then we end up with whatever you just wrote down. So maybe I'll just highlight it. Sine theta is here, sine theta is here, cosine theta is there, cosine theta is there. So the expression that's in front of it, the pink color one, is r cos alpha equals to square root of 3. And what else? We also got this 1 here and this r sine alpha here. Now notice that this choice that I made for the sine theta minus alpha allows me to have a minus sign over here, right?
Yeah, so it becomes
that means
positive.
Very good. Yes, r sine alpha is just the positive one. I don't need to include negative. If I use a good choice of the r formula. Okay, there's 4 choices, right? Oh, I should write down the 4 choices. Lazy, just write plus minus.
Okay.
Okay, so yeah, 4 choices. 4 choices. You need to pick wisely, so that you avoid negative signs. So r sine alpha equals to 1, and call this equation 1, call this equation 2. If I take 1 square plus 2 square, what do I end up with? Left hand side, r square cos square, right? Plus r square sine square. You can always factor out the r square, then you're left with cosine square alpha plus sine square alpha. What's so special about r square plus cos square? Sorry, cos square plus sine square?
1.
Yeah, it's just 1, right? So
R square equals to
r square times 1. So equals to right hand side, square root 3 square plus 1 square, which is 3 plus 1 is 4, equals to 4. Okay, so r equals to square root of 4. Do you need to plus minus?
yeah.
Here, by convention, okay, no. R more than 0. So no, don't need plus minus. Just square root 4 is good enough. So r equals to 2. Is that okay?
How many not R more than 0?
Oh, by convention. It's just a convention and it works.
Okay.
Yeah. If you want r to be negative, let me think. Would it work? If r is negative, let me think a bit. Would the formula still work out? Or if r is negative, you have to be a bit more careful when you're trying to find the alpha, because you're gonna take r sine alpha divided by r cos alpha. I guess it still works. I mean, if r is negative, negative on top, negative below, they're still going to cancel. But just to keep things positive, it will work. Okay. Can you trust me?
Okay.
Just keep it positive. The positive 2 will work. Don't need negative 2. Then the next thing to do is to take the number 2 divided by number 1, exactly what you did. Okay, which is r on the left hand side, r sine alpha over r cos alpha. Then on the right hand side, it will be 1 over square root 3. Anything special about r and r? Yes, because it's not 0, right? That's why we can cancel them off. We are not dividing by 0 over here because r is strictly more than 0. Positive over positive, they'll just cancel away. Then sine over cosine is nothing but tangent alpha, which is 1 over square root 3. Then therefore, you can solve for alpha. Alpha is the reference acute angle. So this is just 30 degrees, right? Good. So now we can combine all of our information. We have r, we have alpha, and as a result, we conclude that the very first line we wanted, square root 3 sine theta minus 1 cos theta equals r sine theta minus alpha. You just need to replace the r, replace the alpha with 2 and 30 degrees, respectively. Okay, 2 and 30 degrees. The theta remains up. Okay, can? So what's the purpose in doing that? What we have done is we have converted a situation where there are the thetas in 2 places, 2 terms, two separate arguments. Now it only appears once, theta in 1 place. Theta in 2 places versus theta in 1 place only. Okay? Good. So now go back to the original question. What was the original question? Square root 3 sine theta minus cos theta equals to 7. Right? This was the original question. Now it's just a simple matter of substituting the left-hand side with whatever we just found equals 7. How to solve? You just have to divide by 2 first. So 7 over 2. I just realized this is impossible to solve because this is 3.5. So sine of an angle must always be in between -1 and 1. So we cannot solve. Sorry, badly designed question. Can I just change the 7 to something smaller?
Yeah.
Let me think. I'll divide it by, maybe I'll just pick 2. Actually, let me think a bit more. I'll just pick a 0.5. Okay. 0.5. So if it's 0.5, I have to redo the whole thing. Let me see what happens. Okay. Everything else also changed to 0.5. Yeah, so yeah, nothing changes with the R formula thing. It's just that the 0.5 now becomes 0.5 divided by 2. So it's 0.25. Oh, no, 0.5 first, then 0.25. Here you're using R formula. Okay, then after that, you can find your alpha. So alpha, I'll just put in bracket alpha equals to what? just take the sine inverse of 0.25, right? That would be 14 point. Okay, maybe I'll work in radians. Let's just assume that this is 0.5 radians. All right. Then in that case, I actually does it even matter? No, it doesn't matter. No, sorry. Yeah, you can just find the degree, the answer in degrees. So that would be sine inverse 0.25, 14.477 degrees. Right? And this 0.25 is positive, so therefore the angle inside must also be in quadrant 1 or quadrant 2. AS. These two. Okay? I'll just write it down at the side. AS, TC, these two. So theta minus 30 degrees. You don't need to split them up, okay? Please don't split them up. Just group them together. Treat as one lump. And this will be equals to the acute angle, quadrant 1 angle, or that same angle, the same argument. We call this the argument, a sign of something. Whatever is inside is called the argument. The argument equals to the obtuse angle, so 180 degrees minus. Okay, then from there you just bring the 30 over and you're done. Can? Assume that the theta is in between 0 to 360. That's my default assumption. Inclusive of 0, inclusive of the 360. So even though 0 and 360 are the same angle, I just include both. Yeah, so therefore theta equals to, I'll just finish up, 44.477 degrees. Round off 1 dp, 44.5 degrees. Next one is theta equals to 180 minus 14.477 plus a 30, and you get 195.523 degrees. Round off to 1 dp, 195.5 degrees. Okay?
Okay.
Yeah, so that's one example that will demonstrate how to do all the other examples. The rest of the examples, you just need to follow whatever the question tell you, or sometimes you have to be creative and figure out which one to use, which of the 4 versions of the sine theta plus alpha or minus alpha, or cosine theta plus alpha or cosine theta minus alpha, which one to use so that you can avoid negative signs as much as possible. Like over here, because of this choice of r sine theta minus alpha, I managed to avoid having a negative sign on the right hand side. These positive square root 3 and positive 1, there is no negative signs. Okay, let me just write this down. RHS square root 3 and 1 are not negative. Are positive. Okay? Because of a good choice. Because good choice of our formula. One good choice of one of the 4. Okay? And that's what we should strive for, so that we can avoid having to take tangent inverse of a negative value and then you scratch your head about whatever is alpha. Not worth the time. Okay, so now that you have seen for one example, I think we are ready. We can just go on to do practice examples, practice questions already. Okay. Yeah, let's just go. So let's take a look at this worksheet. Should I start from basic? Do you think you can do this already?
I
Should I
don't
just
know.
go? Okay, I go through just one. Maybe I'll go through question 1D. Then I think you should be able to do. We'll see. Haha. Quite okay. It's not that bad. Let's go question 1D. So let's try question 1D. You have sine theta. Okay, sorry. Wait, let me copy down the formula for you first. Over here, I'll paste it. The compound angle addition angle formula. Yeah, so you have 4 choices. Which one would you like it to be? Equals to R what?
Yeah, make it positive. So
Yeah, make this a bit bigger. You see sine, you see cosine, right?
yeah.
So you look at these formulas. Which one? The first term must have a sign, then followed by a minus, and then okay, there's a 1 here. Something times a sign, followed by a minus, followed by a something times a cosine. So among these options, do, re, mi, fa, which one has a minus? Let's focus on the minus. Only
Okay.
two options, right? Here or here. So which one? First term involves a sign. First term involves a sign. So you compare first term. Which one involves sign?
This one. So sine A minus B.
Exactly. Theta minus alpha. Not A minus B, theta minus alpha.
Yeah.
Sorry, sign. Easy?
Okay.
Can understand now? Yeah, just look for the sign here, then figure out. 1, 2, 3, 4. You only got 4 options. Just by elimination, you can tell minus sign only allows for these two. And then the first one requires sign. So there's only this guy that has a sign, right? So we have to use this formula, no choice. So let's just expand it out. R bracket sine A cos B minus cos A sine B. So as a challenge, as you do your homework, is to memorize the formula. You go and
The
is it worth it?
compound. The compound. But I can just every time I can just
You can just refer, right? Okay,
Yeah.
no point. Fine. Okay. That's not the point of mathematics. You shouldn't memorize, but it will be faster. You'll definitely see this again when you study physics or engineering. But anyways, let's just expand this out. I'm going to do a trick here. Then cos alpha, then sine theta. So I write it straight away like this. And then minus r sine alpha cos theta. Now I have no idea what is the standard formula. I know some people will go and memorize the formula for r and formula for theta, tangent inverse, whatever. I don't bother doing that. I just compare coefficient. Okay, I think it's simpler that way. 1 negative square root 2. R cos alpha minus r sine alpha. I don't need the minus, just focus on r sine alpha. So as a result, I get what? Yes, exactly what
R
I get.
cosine alpha equal 1. R sine alpha equals root 2.
Root 2. Well done. Good. Then why? So okay, let me just copy down what you wrote down first. Cos alpha equals 1. Sine alpha equals square root 2. Let's call this equation 1, equation 2. Then what do you want to do to solve for r?
Then
solve for alpha first. Also okay. Sure.
Wait. I understand. Wait. So we solve for r or alpha or like what thing?
Both. You need to solve for r and alpha so that we can substitute in the r and the alpha. It's like a identity, trigo identity.
Okay.
Why not?
So for solve for alpha is tangent theta equal root 2 cos equation 2 divided by equation 1.
Exactly. Yes. Good. And then therefore alpha is tangent inverse of that square root 2 over 1. So some people like to memorize square root 2 and then 1, then just straight away tangent inverse. Here you don't need ASTC because alpha is always acute angle, always guaranteed. Maybe I should write this down. Sorry, let me just write that down first in the notes. By convention, r more than 0 and alpha acute. Okay, r more than 0, alpha is acute. More than 0 degrees.
I can just calculator.
Yes, correct. Just tangent inverse on the calculator. Yep. So I have no idea. What is that value? Tangent. Let's just work with degrees. Forget radians. In the future, if you study electrical engineering, you'll have to use radians. Definitely, all the way. No more degrees, I think. Okay, so now we got alpha. How to find a? How to find r?
Do the square 1 square plus 2 square.
Yes, so we get r square cos square alpha plus r square sine square alpha. That's the left hand side. Right hand side, 1 square plus square root 2 square. Okay, so yes, it's just r square times 1 equals to 1 plus 2.
I equal root 3.
Very good, exactly. So therefore, you can just go straight to the top line and just write down square root 3 sine. I'm running out of space. Never mind, I'll just write a new line. So 1 sine theta minus square root 2 cosine theta equals to r is square root 3 sine of theta minus alpha, which is 54.735 degrees. Yeah, okay, very good. So yeah, that's it to the question. Basic level 1 question. You should know this as a first step before doing the application question. Okay, so just just to test you, can you tell me what's the maximum value of this? What's the minimum value? What's the period?
Max, mean, and period. Okay, I mean, max is root 3 minus root 3.
Yep.
Period is...
This only moves the graph left and right. When you see minus, it will move the graph towards the right.
So,
does it change the period? Nah, it doesn't. You should be focusing on the number that's multiplied in front of theta. 1 copy of the graph in 0 to 360, so period is just 360 degrees. All right. Very good. Have I shown you the graph before? Sine of theta minus 54.375? No, huh? Okay, I'll show you. This is
just move to the left.
Yeah, just move only. Exactly. That's as simple as that. Okay, let me just draw the graph. So let's see. We start with, okay, here I just use x because of the software. I have to use x. I cannot use theta. It looks like this, right? Sine graph, the red one. Can see, right? Good. Then if you just change it into square root of 3, so slash sqrt, and then a type of 3. I don't need a slash, sorry. Square root 3, then sine open bracket x. You get this version, the blue one. What's the difference? You stretch it. Can you see? The points that are intersecting the x-axis, they don't move, right? They don't move. But the rest of the points that are above the red, they go further away from the x-axis. And those that are below the x-axis, below the red, those that are below the x-axis, you multiply by square root 3, it becomes even more negative. So that's why it stretches further from the x-axis. The blue is like the red version, but stretched downwards for the part that is below x-axis. And the blue is stretched upwards from the red one when it is the region of the graph which is above x-axis. Basically, you stretch. Is that okay?
Yeah.
Then after that, you copy and paste this. But this time, I'll just hide the old graph. This is the original blue graph. And the green graph is about to change to square root 3 sine x minus, what was that angle? 54.735. Can you see that? What happened? The graph moves rightwards. Is it? Not? Right, sort of, huh? It moved rightwards by the 54.735 degrees. If you want to see an animation, I can change this into an A. Okay, like this. And let me just change this to 54.5. And this one is, I don't know, 0 degrees. Okay, so maybe I'll start from 0. Like this. And can you see the green graph? It's overlapping with the blue one. Now I just press the play button now. Oh, okay, that's very intense animation. I think there's a lag, so you can't exactly see it very, very well, but I'll just move it slowly. So this is the original when A goes 0. Then if you slowly increase it, what do you notice? What happened to the graph? Move a bit more. Move a bit more. Move a bit more. It's moving towards the
right.
Yes, correct. It's moving to the right. Optical illusion, it may look like it's moving towards the left, but it is moving towards the right. Okay, so it's actually 54. And I realized a mistake here. Sorry. Decimals can only work in radians, so I actually need to take the A and I multiply it by pi over 180. So sorry, I forgot about that. Yes, it can only work in. You shouldn't move so fast. Yeah, I have to convert from A being what we want as degree 54 point whatever degrees. You have to convert it into radians, so times pi over 180 over here. right? Okay, then now I slowly move the cursor. What do you see? The green graph now is currently overlapping with the blue, but as I move it towards the right, do you see that it is slowly moving towards the right?
Okay.
Can all? I think this is more convincing. Okay, so minus, then you'll move towards the right. Plus, what do you think will happen? Let's try just for fun. Square root 3 sine x. If I go and plus angle, let's say 10 times, and then I need to multiply it by pi over 180. Oh, sorry. Pi. What happened? What happened to the graph? Before, after. Blue turned into black. When
Move
I plus
to
10
right.
degrees. Move to the left by 10 degrees, right? Which is really just 10 times pi over 180 radians. Okay? Yeah, so that's the pattern of for what do you call it? For trigo graphs. In fact, this is more general than that. It's not just for sine curves or any kind of functions. Let me just show you a quick example. Let's say that we have y equals to, I don't know, x minus 2 square, right? And let's call this f of x. Just like sine x, right? But now it's f of x. If I type in f of x minus 2, what do you expect? What do you expect? I mean, okay, maybe I shouldn't have used x minus 2 squared. Let me just expand it out. So to not confuse you, minus 2x plus 2. Red graph is this guy, x squared minus 2x plus 2, right? Okay, maybe 4x. Okay, not much difference, doesn't matter. Then the blue graph, do you see what happened?
Move to the right.
Yes, it moved to the right. So at first it was f of x, now become f of x minus 2, minus, then it moves towards the right by 2 units. How about if I change it to plus 2? What will happen? fx become fx plus 2. This time it started from the red graph and it moved towards where?
Left.
Left by how many units?
2.
2, exactly. Okay, that's graphical transformation, H2 math topic. But you only need to know the application to trigonometry in AMAX. Okay, yeah, so that's why people who already took AMAX, they already seen graphical transformations, but in H2 Max it's just generalized to any kind of functions. So that's why you should, yeah. So anyways, you have already learned a little bit about graphical transformations. So yeah, that's it. What's so useful about this? What's so useful is that you can use this to answer questions, right? That's the main point. Do you need me to go through the rest of the examples? Because I realized that I am using r sine theta minus alpha again. I think maybe I should go through one more example. How about part B?
Okay.
Okay, let's go through part B. So square root 3 cos theta minus sine theta. Let me copy down the question first.
Okay, cosine alpha, and then
yes.
minus sine alpha, sine alpha, and then okay. So I need minus.
You need a minus. So here
Yeah,
and
here,
here, right?
here and there. Okay, and then I need
Cosine on the left, sine
cosine
on the right.
sine on the right. Okay, then I think is this one.
Actually, both can work. Both
Oh, okay.
But let me see which is better. Let me think a bit. If I use, yeah, both can work. Yeah. Which one you want? A minus B, theta minus alpha? Can. Hey, but it's the same. You see, you're using the same example. Then not fun. Not
Okay.
Never cover more variety. So how about if we pick the other guy? It will your a minus or theta minus alpha, sine theta minus alpha will work. But just for variety's sake, I will pick cosine A plus B. No. Cosine theta plus alpha. Okay. Then yeah, let's just bring it down because I need more space for the working. So over here, let's see what happens after we expand this. We'll get r times cos minus sine. cos theta cos alpha minus sin theta sin alpha. Very good. So we multiply the r in. What do we get? R cos alpha times r cos alpha times cosine theta minus away r sin alpha sin theta. Compare coefficient, you get what's this? Square root 3 is r cos alpha, -1 is negative r sin alpha. So you actually don't need the negative, right? Just focus on the one invisible one here. So 1 is the same as, just don't underline the
Sin theta.
just r sin alpha. Exactly. Okay, then you can just start to compare. So therefore, r sin alpha equals to 1 and r cos alpha equals to square root 3. I purposely write the sine on top and cosine below. Why? So it's easier to see the tangent. Okay, you get it. Yep. So therefore, tangent alpha, you just have to take the 1 over square root 3. Alpha is 30 degrees. Good. What else we have? We want the r value now. So you just take the square of each term. This one, maybe I should write down 2 divided by 1 somewhere, just to remind ourselves. Oh, 1 divided by 2 in this case, sorry. Yeah, just be flexible. You know it must be sine divided by cosine. Sine on top, cosine below. So don't just blindly memorize 2 divided by 1 or 1 divided by 2. Just you should memorize sine over cosine. Okay, sine divided by cosine. And yes, r square is just 1 square plus square root 3 square, which is just 1 plus 3, which is 4. And therefore r equals to square root of 4, which is just 2. So we got r equal to 2, alpha equals 30 degrees. As a result, we will be able to get this expression here to be equal to 2 cosine theta plus 30. Okay?
Okay.
Yeah, it's guaranteed to work. You can also use sine theta, r sine theta minus alpha, and then you compare, it will also work. So this is a bit flexible in that sense. Okay?
And how do you solve this?
Which one? Oh no, you're not solving. This one, you read the question. Express each of the following as a single trigonometric function. So you're not solving anything. This is just question 1, no solving.
Wait, what does it mean?
Whatever we did,
Oh, okay.
present it from this, got cosine and sine, 2 separate trigonometrical expressions into this expression, only one trigo expression. And it's not equal to like 7 or anything. It's just a trigo expression, not an equation. Just like proving trigo identities, right? You're not trying to solve for any theta, right? Just show an identity. Okay, this is still under the trigo identities topic. Yeah, it's just but with applications to solving equation. Okay, so now time for application. Let's move on to question 2. Actually, is question 2 interesting? Maybe I can go to something more interesting. I'll skip question 2. Let's look at this AC current. Wow, got math involved, got physics involved. Okay, so the current I in amperes is an alternating current circuit, and it's given by the following formula. I have no idea what is alternating current. Sometimes go up, down, up, down. I don't know. Doesn't matter because I just need to know the math, which is I equals to whatever. Okay, where t is the time in seconds. Now part 1 asks you to express I as a single sine function. So let me copy down the question first. And the formulas that are relevant. So we don't need to keep scrolling up and down. Copy, scroll down, paste. So how? Expressed as a single sine function. So what is the, so they're basically saying restrict your choice. I hope you can tell that it's like a times sine something and then minus b times cosine something. So you need to use R formula. And they are telling you as a single sine function, so they are restricting your choices already. It must be R sine something. Which one? Only 2 choices, right?
Yeah.
Minus in between, so which one?
The second one.
So theta and alpha, what's in between? If you want minus here, it's also a minus there. Okay. Let's say if I give an extension extra, if I want cosine instead, which one would I want to pick? Theta here, alpha there. What's in between? Here cosine not such a good choice because we need a sine, right, on the first term.
Yeah.
First term and the second term. Here both are cosine. So okay, no, sorry. This question cannot extend. Cannot use cosine. Just r sine theta minus alpha. Okay, so we expand it and what we get. Let me just expand. R sine theta cos alpha minus cos theta sine alpha. Distribute the r, we get r cos alpha sine theta minus r sine alpha cosine theta. Compare coefficient. So over here actually we should be a bit more sorry, I made a mistake here. I used theta. But actually the angle the variable they use here is what? T. T. Okay. Actually not just that. They didn't use just T. They use 120 pi T. 120 pi T. Can you see that? So you know what? Let me just be a bit lazy. I'm just gonna say let theta equals to the 120 pi T. Okay, so the question now changes to I equals 15 sine theta minus 8 cos theta. Just remember I did this substitution at the end. Later I need to replace it back with 120 pi T. So anyways, we found out that this will be equals to that r cos theta sine. I'll just copy everything down. You let this be equal to this, and then simplify into this. Then you compare coefficient. So same procedure lah, So r cos alpha is 15, right? This part is the same as this part. Then there's the 8 is the same as r sine alpha. So write that down, r sine alpha equals 8.
Alpha equals tangent inverse 8 over 15.
Yes, correct. Good. So theta. No, alpha. Yeah. Then what else? Okay, we'll calculate that later, but how about r?
R square equals to 15 square plus 8 square.
Yep, exactly. So square root 15 square plus 8 square. Doesn't this look like Pythagoras theorem?
Wait, no. Wait.
17. Right?
Okay.
Yep. Okay, good. So tangent inverse. Okay, let's just calculate that first. 8 over 15 is it? Did they request for radians? Okay, let's just for variety, let's work with radians now. So this will be 0.48995 radians. Okay?
Okay.
Nothing much. I just change the calculator mode. Nothing difficult. So now we just need to substitute in, and therefore we get I equals to 15 sine theta minus 8 cos theta equals to 17 sine theta minus alpha, in this case using radians, 0.48995 radians. Yeah, but remember the original question, did they give us theta? No. What did they give us?
120 pi T.
120 pi T. So therefore, we should answer the question by rewriting it as, in terms of 120 pi T. So let me just quickly do that. In other words, I is actually equals to 15 sine 2 theta. Oh no, 120 pi T. I need to write how many times? 120 pi T. 120 pi T. 120 pi T. Okay? Just to answer back to the question. Okay, good. Then how? Let's read the question. Part 2. That was part 1. Find the amplitude of the current. Amplitude is what? Amplitude in this case, they already told you is I. It is I, right? I equals Q over T. Oh, what's that? I have no idea. Amplitude of the current. So how? Amplitude. Sorry. I is the current. Then the amplitude is basically asking you draw the curve. What's the amplitude of the curve of the trigo graph?
17.
Yes, it is 17. Okay, that's your answer. That's all. Easy. Right?
Okay.
Very good. Okay. It's just math. Right? You don't need physics to know what is amplitude. You need math instead. Okay, very good. Moving on. Let's go to the next question. So all basic questions. Question 3. Okay, too easy already. Let's try something more interesting. Let's say, which is better? Find maximum minimum. Yeah, you know the procedure, right? Finding maximum minimum. Just use R formula, then the answer is R. Maximum is positive R, minimum is negative R. Right?
Okay.
Clear? I'll leave you to do on your own question 4 if you want.
Wait, can you say that again?
Maximum is positive R, minimum is negative R. Just use R formula.
So
Pick
just
one of the
same
correct
thing.
formulas.
Just
Yeah.
same thing.
Yeah, it's just an exercise, boring exercise. Just use
Wait,
the correct
do I
alpha.
still need the to find the alpha?
Yes, they said find the corresponding values of theta. They requested for it.
Oh,
Yeah, so need lah. Huh? Just
okay.
for practice only. Do you want me to go through example?
Nah, it's okay. It's okay.
Can I think it's better if you try solving equation. That's the main point. That's the main purpose of this R formula, to solve equations. So solving each of the following equations for 0 strictly less than x strictly less than 360. So we cannot have answers equal to 0 equal 360. So let me just copy this down. Part. Let me see which is more interesting now. I think you already get it, right? You know how to use R formula already. Yeah, you just need to see examples. Okay. Okay, so let's see. Maybe I'll just try question 5 part A. 3 cos x minus 4 sine x equals to 1. Solve each of the following equations. Keyword solve. Okay. How? Can we just bring the sine over, then divide by cosine, get tangent? Cannot, Why?
No, because yeah, the extra term.
Yes, extra 1 at the right hand side. Remember at the very beginning, I told you we can only get the tangent, don't need R formula here, when it's a 0. Special case, right hand side equals to 0, can get tangent theta without using R formula. Whereas this guy, you need R formula when it's not equal to 0 on the right hand side. And of course, the format of the left hand side is always A times a sine theta or cosine theta plus a B times a cosine theta. Okay, this format. Of course, the plus can be a minus. Okay, plus minus. The LHS is of this format. Then the right hand side, sometimes it's 0, sometimes it's not 0. When it's a 0, just use the trick that we went through over here. Bring the cosine over, divide throughout by cosine, get a tangent theta. And if it's not a 0, then you need to use R formula. Okay, so I hope you can tell now this is not 0, so therefore we need to use R formula. It's of the format A sine theta plus B cos theta. Okay, so anyways, which form do you want? The procedure is let 3 cos x minus 4 sin x, the left hand side, equals to R something. Which one?
Minus, have a minus. And then actually you can use the sine one.
Yes, correct. Okay, let's do that. Sure.
But actually can you use both?
You can use both. Correct. Yes. Which one you want?
It doesn't matter then.
Yeah, it doesn't matter. Okay, good. You get a point. Okay, so let's just say we use sine since you said that first. So sine, is it A minus B? No, it's theta minus alpha. Try to use the correct notation so you don't get confused. Theta minus alpha. Expand. Sine A cos B minus cos A sine B. But the A being theta, B being alpha. Distribute. r cos alpha times sine theta minus r sine alpha times cos theta. Compare coefficients. In front of the, oh, sorry. I made a mistake here. What's the mistake? The angle they use here is x. Here I go and change to theta. That's not good. I should instead maybe contextualize. I can let theta equal to x, but I think I'll just adapt. I adapt to them. So I use theta. No, I say I adapt, I still don't adapt. Okay, change it to x. Is that okay with you? Okay, so far, can yeah, so then you compare coefficients. So 3 times cosine x. Here there's a cosine x. The number in front is, wait a minute. Did I do something wrongly? Let me see. Oh, Does it not work? Oh, that's a problem. Do you see the problem? I guess there is only one correct choice. Do you see the problem?
Wait, let me think. Wait.
You want to compare cosine x with cosine x? Here's cosine x. Here's cosine x.
Minus r sine theta
Oh,
equal 3 cosine. I mean 3.
There's a minus now. So you have to compare with you. So you have to let negative r sine alpha equals 3. If you really want to use it. It is possible, but that is not what we recommend because there will be negative signs. So actually sine x minus alpha is not a good choice. No. Oh no. Throw away. So what's the other option? Previously we found minus sign, then we just pick this one. I guess it isn't such a smart choice. We should have picked this one instead. Cosine instead. Is that okay? Let's see. Then let's just sub it in. So instead of a plus b becomes x plus alpha. Expand it out and we will see it just works. Cos a cos b minus sine a sine b. Right? For cosine it's a bit special. Plus will change to minus. Okay? Right? Then expand. So r cos alpha cos x minus r sine alpha sine x. Very good. Let's compare. Wow, very nice now. Cosine x on the left, cosine x on the left. Then we can just compare 3 with r cos alpha. What else? Sine x on the right, sine x on the right. Minus in between, minus in between. So we can just compare 4 in front of sine x, r sine alpha in front of sine x. So the box must be the same as the box. The underline must be the same as the underline. So therefore, r cos alpha equals to 3 and r sine alpha equals to 4. Okay, sorry, I made that mistake over here. This is a bad choice. No, cannot. Are you convinced that this is a bad choice already?
Yeah.
Yes, you have to involve a negative r sine alpha. Negative in front of the r sine alpha, which is not very good. Okay, now that we have picked the good choice so that our values are all positive, let's proceed. Tangent alpha equals to r square equals to
r square equals to square root 3. 3 square plus 4 square. Then for r is square root that, which is 5.
Very good. Getting faster already. Yes. Therefore, we get we need to find alpha first. Tangent inverse. Can you tell me what's the angle?
In radian.
Sure. Okay.
I don't want.
Sorry. Do you know how to type in radians? I mean,
they just change to radian mode, right?
Yeah. Correct. Second mode, then radians. I mean, depends on your calculator model. Change to radian mode. Yes. Okay.
It is
0.92729.
Yeah.
Yes, okay, good. So now we can finally substitute our left-hand side here with r cos x plus alpha, where r and alpha was already found. Okay, so back to the original question. We conclude that left-hand side is just r cosine x plus alpha equals to 1, which is really just 5 cosine x plus 0.92729 equals to 1. Okay, we are replacing the left-hand side here, this guy, with r cos x plus alpha, r cos x plus alpha. Then we replace the r, we replace the alpha. Is that okay?
Mm-hmm.
Can good. And then finally, you take the division by, you divide by 5 first, then you cosine inverse. Okay, this one is positive, so the alpha must be cosine inverse 1/5. Let's just work with radians. 1.3694 radians. Cosine is positive, ASTC. Which quadrant is it in?
It is in fourth and first.
Okay, so if it's the first one, then x. So is it just x or is it x plus 0.92729? Equals to the first quadrant angle. Is it just x or is it x plus? When I write this down, must have a plus, exactly. You must take this entire angle here. Okay, now that is for the quadrant 1 angle. I'll just put bracket Q1. Or, I need more space. Or you take this same argument here. Don't forget, don't drop the numbers here. 0.92729 equals to the quadrant 4 angle, which is what? How to find quadrant 4 angle in radians? Acute angle is this guy. How? How to find a quadrant 4 angle? Let's say if it was in degrees, let's say this was like 10 degrees.
2 pi minus.
2 pi minus, exactly. Very good. Okay, and then after that, just bring this over and solve. Yeah, so I'll just do it. 1.3694 minus away 0.92729. Type in the calculator, what do I get? Let me just calculate it. It's 0.44211 radians. Next one will be x equals to 2 pi minus, and then minus away 0.92729. 2 pi minus 1.3694 minus 0.92729. Type in the calculator and what do I get? I have no idea. I need to use a calculator. And I end up with 3.9864 radians. 3SF will be 3.99 radians. 3SF will be 0.442 radians. Okay, can. And we're done. Okay?
Mm-hmm.
Good. Okay, let's try another interesting one. Let's say we do part F. Pi times cosine x plus e sine x equals to 2. Huh? How come got pi? How come got e? Don't worry, what is pi? It's just a number, 3.14159. What's e? E is also just a number. 2.7, 1828, 1828. Okay, just a number, right? Can? Good.
Okay.
Then which one? Which choice?
Plus and plus. So use sine. Yeah.
Here, maybe let me think a bit. Let me think a little bit. How do I explain this? You see, look at this formula here. from part A. Cos x, is it in the first term, right? There's a cosine x and cosine alpha. Is the cosine x versus the cosine alpha, is it on the left or on the right? Cosine x is on the left, okay? Within this box, within this red color box I'm drawing, there's a left, there's a right, left and a right. Cosine x is what we want. It appears on the left. Okay, in the formula, it will also be on the left here, cos A. But then at the end of the day, we needed. Okay, yeah, so it's on the left. Okay, that's all I want to say. And on the original expression, we got cosine x, right? So that means that we need the cosine x to appear on the left side of those expansions that we have. Okay, that's how we decide to choose cos A, the one involving a cos A, because it appears on the left. The A becomes cos A, the x becomes cos x. That's how we decide to choose this option. Whereas for this guy, actually this guy we see plus sign, so we know that it's either this guy or that guy, the first one or the fourth one. Then we see, oh, I need a cosine x at the end of the day. So if it should appear on the left side. No? So it should be cos A minus B.
Oh.
Does it make sense?
Yeah.
Can, right? I hope it makes sense. And then the sine A will be your sine theta or sine x. Cos A will be your cos x. Right? So we should pick the fourth option, cos A minus B. Is that okay? Can, okay, I'll just copy this down. I need more space for the working. And I will copy down the compound angle formula. This is question 1 again now. What was this question again? Question 5. Okay, so again, this is not a constant 0. This is not 0, so we cannot do the trick, bring over and then divide by cosine, get a tangent. So instead, we need to use R formula. Okay, because it's in the correct format. A cos plus B cos, B sine. Something times cos plus something times sine. So we need to use R formula. How to present it? We say we let the left-hand side expression, copy and paste, equals to R times the correct choice. In this case, we have identified the fourth one to be the one that has the least trouble. So A minus B, but in this case, do we write down A minus B? No, what should we write instead?
X and alpha.
Very good, X and alpha, not theta and alpha. So you expand it out and you get what? Cos, okay, you tell me how to expand it. Read out for me, I copy it down. I write for you. Cosine X minus A alpha, sorry.
Cosine X cosine alpha plus sine X sine alpha.
Multiply in, what do I get?
R, you can put the, wait, the alpha is, wait, the alpha is behind, wait, no, it's cos X behind. Okay, R cosine alpha cosine X.
Correct.
Plus R sine alpha sine X.
Good. It was on the left, but you just swap it around. So the cosine became on the right. And then?
R cosine alpha equals to pi. And R sine alpha equals to E.
Good.
And then
I'll call this 1 and 2.
Alpha equals to tangent inverse E divided by pi.
Yeah, okay.
Then R equals to pi square root pi square plus E square.
Yes, correct. Good. Okay. Yeah, so it's just a bunch of numbers. Let's just round it off to like 5SF. Let's calculate R first. Pi square plus E square. Type in a calculator, I get around 4.1543. Okay, 44, huh? If I really round off 5SF. Then tangent inverse, let's see what it is. E divided by pi, I get a 0.71328 radians, roughly. My calculator was still in radian mode, so I'll just stick to radian. Then, as a result, we can take the original equation, just copy it down. We wanted it to, the left-hand side to be r cos x minus alpha, right? So we just substitute in the r, 4.1544, times the cosine, x minus the alpha, 0.71328, equals to 2. Okay? Then we proceed to solve. Is it okay so far? Clear so far? Can, good. So now that we have this guy, you want to solve for the cosine on its own. You just have to take the 2, you divide by the 4.1544. Very good. So now you just have to divide. 2 divided by 4.1544. You end up with around 0.48141 or 142. Okay, that's cosine x minus something. This is a positive value, so what do we do? Lazy way is just bracket alpha equals. Then you just cosine inverse on the calculator, 0.48142. And I get 1.0685 radians. Approximately. Then, therefore, x minus whatever must be that angle, 1.0685. Or, because ASTC tells me that it must be in these two quadrants, quadrant 4 angle will be 2 pi minus. 2 pi minus. So this guy equals to 2 pi minus away 1.0685. Then solve for x. I'm just going to type in a calculator. Is that okay? I skip past that. And okay, then I end up with 1.78178. Round off to 3SF, 1.78 radians. Oops, radians, then 3SF. Next one will be 2 pi minus away 1.0685. Then you add on 0.71328. And you end up with x to be 5.9279 radians, approximately 5.92. Let me just do a quick double check. This is in how many degrees? 5.92. Just do a quick reality check.
It's
in case.
more is, wait, 3.14 times 2 equals to, it's less than 360.
Yeah, less than 360. So still okay, right? 3.14 times 2, 6.28. So it's less than 6.28, so it's still correct. If you converted it into degrees, it will be 339.64 degrees, approximately. Just times 180 over pi. Okay? Yeah. Just in case you are very confused, you can always multiply by the conversion rate. In case you forgot, let me just write it down for you. Degrees, radians. Let me just get my charger. Hold on a second. Hold on a second. Is it okay? Yes. So degree to radians. What's the conversion rate? It's pi over 180 when you want to go from degrees to radians, and the other way around is 180 over pi. Okay.
Okay.
Yeah, that's all. Good. Maybe I'll put a degree symbol there. Okay. Good. 5F done. Easy. I think you get it by now. Let's just move on to other examples, other questions. Now for application. Application is the one where it's interesting. You need to know how to set up the equation, and then after that, it becomes boring again. Maybe okay at the start they start off by giving you the equation first. They don't ask you to set up yourself. So let's just look at, let's say let's see which is good. Is question 6 good? Okay lah, why not? Question 6, car suspension. It's like mechanical engineering already. not enough. I still need to copy a second half. Okay, let's go. So car suspension function G given by the following: gt equals to 8 cos 40 plus 6 sine 40. It's where t is the time in seconds after starting the car. Part 1, express G as a single function. Okay, so I see that there's a cosine and a sine, right? So straight away I think of it's cosine theta minus alpha, or cosine 40 minus alpha. Okay, take note that over here the angle that is common is a 40, right? So we need to make sure we always use a 40. Okay, then this will be what? Cos minus sine. Sorry, I'm not showing the formula. Is it okay?
Oh, okay.
Can yeah. Then as a result, you just multiply in and you end up with r cos alpha cos 40 plus r sine alpha sine 40. Okay. Good. So you just compare. It's the same story again, huh? Just endless number of practices for you to get used to it. So therefore, r cos alpha equals to 8. And 6 is r sine alpha. Then let's call this 1, let's call this 2. So if I want to solve for tangent alpha, I will take 2 divided by 1. 2 divided by 1. And end up I get 6 over 8. So alpha equals tangent inverse of 6 over 8, which is 3 over 4. Type in a calculator, then r square is equals to 8 square plus 6 square. Right? Because if I just show the full reasoning, it's 1 square plus 2 square, which is r square cos square alpha plus r square sine square alpha equals to 8 square plus 6 square. Factor out the r square, you get cosine square alpha plus sine square alpha inside the bracket equals 8 square plus 6 square. But wait, what is sine square plus cosine square? It is just equal to 1. So therefore, it becomes r square times 1 equals to 8 square plus 6 square. Therefore, r square equals to 8 square plus 6 square. And finally, we can obtain our value of r to be square root of 8 square plus 6 square. Don't need to take the negative square root. Just the positive will do. Okay, let's calculate that. 8 square plus 6 square, this is 100. Square root of 100 is a 10. Okay, tangent inverse 3 over 4, no idea. Just calculate the approximation of the angle. In this case, 0.64350 radians. Very good. So now we have g of t equals to 10 cosine 40 minus 0.64350. Okay? Express as a single function. Express g as a single function. Now for part 2, find the minimum value of g and the first time at which this value occurs. Minimum value and the first time when it occurs. So what's minimum of the g of t?
Minus 10.
Exactly, that's it. Then when does it first occur? Draw the graph.
Won't it just be moved to the left?
Yeah, exactly. So let's just start off by drawing the cosine, the y equals to 10 cosine 4t graph. So if this is t, this is y. Since there's a 4t, that means that instead of 360 degrees, it will be 4 copies. So it's 360 divided by 4, right? For one full cycle, right? That means that everything else also need to divide by 4. So previously, this first occurrence when it hits negative 10 is over here, which is usually pi, right? But you have to divide by 4. Be negative 1. This is, take note, 10 cos 40. But actually, the question is asking about this function, which has a minus 0.635. So you need to move it. When you minus, do you move it to the left or to the right? The graph.
Left.
Wrong. Right.
Right.
Okay? Do you think of it like this? whenever you have a minus, it's like a game. You have a north. So what happens to the hardworking T? The hardworking T wants to make sure that it produces the same Y value. So what does T have to do when there's a north? There's some burden pulling it down. It has to work harder, right? So T has to work harder. So what does it mean in terms of a graph? It means that all of the X coordinates, the T coordinates have to increase by a certain value. So graphically, it means that if you have like, let's say I just plot a bunch of points like this. This is like -2, 5. This is -2, 3. This is like -2, 1. This is -2, 3 again. This is, sorry, I cannot be, how can it be negative all the way? So sorry. -1, this is 0, this is +1, this is +2, and 5. So imagine you have a graph that looks like this. Oh, slanted. Okay, can you visualize that? Got these bunch of points. Then what happened? Then let's say this is y equal f of x. Then what happens when you change it to y equal f of x -1 inside the argument? In order for you to hit the same y coordinates, right? What would the x have to do? The x will have to work harder. You have to work +1 as hard. So that means that the resulting graph, the points what are the points that it will pass through? It will be the exact same points, just that the x coordinate, everything must +1. Can you see that? This becomes -1, this becomes 0, this becomes 1, this becomes 2, this becomes 3, in order to reach the same y coordinates. Okay? Yeah, so you can also do a quick experiment, like let's say -1, 5. If x equal -1, you sub in over here. What's -1 minus 1? What's -1 minus 1?
-2.
So that means that this becomes f of -2. But what's f of -2? Look at this graph and you can find out. X is -2, then the corresponding value is 5.
Okay.
So therefore, that's why the y coordinate here is also 5. And you can repeat the same thing for all the others. Here, that is +1 only because we have a -1 over here and the coefficient of x is 1. Our actual graph here has a 4t. Do you see that? So that means that in order for you, whenever you minus 0.64350, this 4t needs to increase by 0.64350. Do you agree? It's not just t itself, it's 4t. Right? The t has a boost, it's a bonus 4 times. Then in that case, it simply means that your 4t has to become positive 0.64350, which means your t has to be positive 0.64350 but divided by 4. Okay? Let's calculate that. What's that value? It's around 0.160875, which means that this time the t actually has to work harder and it has to increase itself by a value of 0.160875. So that means that the first occurrence where there is a minimum value, it's not pi over 4, it's pi over 4, but you need to plus how much? Is it the entire thing plus 0.64350?
No.
No, what should it be? T only needs to work a quarter as hard, right? Because it already has an extra bonus of 4 times.
Divided by 4.
So therefore, this should be just the actual answer should be pi over 4 plus 0.160875. That's your answer. First time when minimum value -10 is reached. Are you convinced? Okay, let's just calculate the numerical value of this guy. So plus pi over 4, and I end up with, let's see, plus pi over 4, I end up with 0.94627 radians. Is that okay?
Okay.
Now, have you recorded this down, 0.94627?
Okay.
Have you recorded down the question? I'm about to change the screen now. G of t equal to 8 cos 4t plus 6 sin 4t, as well as the resulting 10 cos 4t minus 0.64350. Can?
Okay.
Copy already?
Uh-huh.
Okay, now I'm gonna change screen. Wait a minute. Just to further convince you that my numerical working is correct, you can always use a graph. Use more powerful technology. So instead of 4t, it's 4x. So 8 cos 4x. Oh my goodness. Let me just zoom out first. That's not very good. Yeah, 4t that's why it looks so intense. But we still got a plus 6 sine 4x. Looks even worse. Let me just change the scale first. Negative maybe 6.28 and this one positive 6.28. Pi, maybe I don't need so much, just negative pi, then pi. Okay, good enough. Y-axis, okay, I think this is good enough. So this is the resulting graph, okay, the green one. But whatever we have found numerically, like using our formula, is that this g of t is actually 10 times the cosine of 4x minus approximately 0.64350 radians. Can you see the purple graph? Okay, now I'm hiding the purple graph. I show you the green graph. I show the purple and the green. Purple, green. Do you notice that they look the same?
Yeah.
Yeah, that's why. But actually, it's not exactly the same because the 0.64350 is an approximation. If you want it to be exactly the same, you need this to be super, super long. The accuracy of the alpha that you found has to be super, super accurate. But I think you can tell that they are almost exactly the same. You see, even if you zoom in all the way, there's just not much difference at all. Here, okay, you can start to see the difference. If you zoom in fine now. Right. There's a slight gap, but there's a very, very, very extremely small scale already. So by approximation, it's almost exactly the same. If you zoom out, like I zoom to the normal, oh my goodness. I zoom to the normal scale, then you realize that actually it looks very, very okay. The approximation is very good already. Okay? Approximation is very good. So let me just change my scale back to a nice scale so it looks nice. Something like this. Okay. Anyways, we'll be working with this purple guy. Now the minimum value is negative 10, right? Over here, can you see? Then do you also see 0.946? So that's our answer, 0.946. Our answer 0.94627 radians, as shown from the graph. 0.946 is the first value of t such that it reaches negative 10. Okay?
Okay.
Yeah, another way to do it is y equals negative 10, you draw the graph, then you find the point of intersection here between the graph. So you get 0.946. There's all these other values that will hit negative 10, but we are only asking for the smallest, the first occurrence. And in fact, the negative part doesn't make sense because t must be more positive, right? T is a time. So you can only have positive values of t or 0. Negative values of t, the left half of the graph is irrelevant. Okay?
Okay.
Oh, by the way, you can also change the graph if you're interested. You can just draw a curly brace like this. Then you say 0 less than or equals to x, less than or equals to, I don't know, let's say one, I don't know, 6.2. Then you close the brace. Then what happens? The graph will only be drawn from 0 until 6.2. Okay? It stops at 6.2, 5 point whatever, and starts at 0.8. You can restrict the values of x like this if you're interested in doing it.
Okay.
Okay, good. Okay, just change back to the iPad. Whoa. Okay, that was this question. Interesting question about testing you on graphical transformation. Let's move on to the application. So let's see, electrical circuit, nah, maximum, minimum. Okay, let's try question 8. Question 8, so find the maximum and minimum of the following. I'm just gonna look at question part here. question 8 part D. Okay, so over here we got what? Y equals to 7 plus 15 cosine 2 theta plus 8 sine 2 theta. Now, do you notice that this is no longer just a single theta, but instead it's a 2 theta?
Mm-hmm.
Yes. So you have to be careful. You just treat this as one lump. Okay, just like just now the 4t, treat it as one lump. Okay. Now, how do you find the maximum value and minimum value? The simplest way is to just use the graph. Correct or not? If you have graphical software, you can just type this key, this entire function inside. But instead of 2 theta is 2x. Right? So that that's how the graph works. That's how the calculator works. You must key in x. Then they will draw the graph for you. You just have to read off the graph and find the maximum, find the minimum, and you're done. But of course, that's not the purpose of this exercise. They want you to do it without a calculator, graphical calculator. So how can we do it? Any special patterns you see?
Special pattern.
What? Oops, sorry. Let me get some water. Yeah, think about it. What special pattern? What topic are we at? Formula topic. Nothing?
Special pattern.
I mean, definitely we need to use R formula, right?
Yeah.
Which part? Which part can we use R formula on?
The right part. Like
Exactly. Yes. Yeah, that's it. That's the pattern. 15 cos 2 theta plus 8 sine 2 theta. This part can use R formula, right? But the plus 7, can we do anything to it? Do we let the entire thing equals to R sine something something or cosine, whatever? Or do we only focus on the last 2 terms? There are 3 terms here. To be replaced with a R times sine.
I mean, the
all 3 or only last 2?
The 3.
All 3 are wrong option. Why? Because so far the R formula I've only taught you in the format A sine theta plus B cosine theta equals to some constant C that's not equal to 0, and we replace the left-hand side. And the left-hand side format does not involve a constant. It's only something times sine, something times cosine. Here also something times cosine, something times sine. We don't include the plus 7. Ignore the plus 7. Focus only on the last 2 terms, and then you replace the LHS using R formula. Is it clear? Leave 7 alone. So we're going to do that. So equals to 7 plus, let's just fill in the blank, R times some angle, some ratio, cosine or sine, then something either plus or minus alpha. Then what's the angle over here? Of course, it must be R, right?
Yeah.
At the front. Then what's the angle here? Is it X?
No, it's 2 theta.
Very good, exactly. It's 2 theta. Then which one should we use? So maybe I should copy down the formula first before I keep talking. Yeah, so how? Which one?
Okay, it has to be plus.
So plus here, plus here. The left one is sine A. Left one is cos A. What do we need on the left?
We need cos A.
You need cosine 2 theta, so we link it to cos A here.
Cos A minus.
Therefore, cos A minus B, exactly. Okay, so it should be a minus and a cosine. Then
okay.
Let me expand it. Expand and you'll see that it will be the same. But of course, maybe presentation-wise, let's just leave a gap here. So 7 plus, we'll fill in the blank with whatever is the value of the R and the alpha later. Okay, the box is to be replaced with our answer. So to present it, I should say let 15 cosine 2 theta plus 8 sine 2 theta equal to r times cosine 2 theta minus alpha, right? Good. Okay. Proceed. Expand. Proceed to expand. R multiplied by cos A cos B plus sine A sine B. Multiply the R in to the cosine alpha, then to the cosine 2 theta, plus R times sine alpha sine 2 theta. Now, pattern. Cosine 2 theta, 15 R cos alpha. I'll circle the relevant part and conclude that R cos alpha equals to 15. What else? 8 and R sine alpha must be the same. Yes? Following so far? Very good. So what is alpha? Just do it straight away. Tangent inverse.
Tangent inverse 8 over 15.
Very good. Why do you choose 8 over 15? Is it because it's small on top and big below?
No,
No.
cos 2 divided by 1.
I hope that even if I swap it around like this,
Then
you are
1
not.
divided by 2.
It's always the sine divided by the cosine. That's the key I need you to key thing you should remember instead. Not 1 divided by 2, 2 divided by 1. It should be sine divided by cosine. So that we have tangent, then bring over become tangent inverse. So because we need sine on top and cosine below, that's why we need 8 followed by our 15. Because 8 is attached to the sine, 15 is attached to the cosine. Okay? Can Yeah, let's just calculate it in radians. Tangent inverse 8 over 15 is 0.48995. Okay, and R is equals to square root of?
R is equal to square root of 8 square plus 15 square.
Which is 17. This looks very familiar. I don't know why. Okay, okay, anyways. So what we have now is our R value and our alpha. So we can just substitute it back in here and there. Right? So I'm just going to do that. I'll erase the box and I'll fill in the blank with 17 and 0.48995. Like this. Okay? Can? Yeah, so let me just shrink this down and put it at the side. Now this is our main focus. Can you tell me what's the maximum and minimum? Cosine, always in between -1 and +1, right?
Negative
You times
7.
17, -17 to +17. Right? So this, maybe I'll just write down the working like this. It goes from -1 less than, okay, how do I write it? -1 to 1. This one will be -17 to +17. But the moment you +7 to it, what happens? +7 +7. So it becomes -10 to 24. Make sense? This is a simpler version. I don't know if it's simpler or not, but a simpler version of inequalities. Okay, the proper way to present it would be instead of saying -1 to 1, you should be saying -1 less than or equal to cosine 2 theta. Just to make my life easier, I'll just let x equals to 2. Let x equals to 2 theta minus whatever. Then I don't have to write so much. Yeah, so in general, for any angle x, -1 is less than equal cosine x, less than equal +1. And if you times 17 to it, then you go from -17 to 17. So like this. Right, this is the proper way to write it in math notation. Then after that, you +7 to it. So +7. If you +7 in the middle, you also have to +7 all the way. So -17 +7, 17 +7, which is just -10, +24. Let's just present it a bit nicely, a bit nicer, in a nicer way. So -10 less than equals to 7 + 17 cosine x less than or equal to 24. Okay, This is the formal way to present it. This is the corrupted version.
Okay.
Okay, so tell me what's the maximum, what's the minimum? This is really just y, right?
Uh-huh.
So what's the maximum y? What's the minimum y?
Max y. Wait.
Huh? Why?
Isn't it just 24 minus 10?
Exactly. That's why I'm waiting. Yeah, it's very simple. Yes, yes. Good. That's all. Easy.
I never said that.
Yes, yes, very good. Okay, so you can proceed to do the rest if you want. I'm just gonna move on, but you get the idea, right? Use R formula, and now it's just application. How do you find maximum and minimum? Maximum is plus R, minimum is negative R, but you need to plus a 7. So this one just have to plus 7 to each of them. So it's positive 7 plus 7, negative 17. Sorry, positive 17 plus 7 and negative 17 plus 7. Right? Positive 17 plus 7, negative 17 plus 7. You get your minimum and maximum.
Okay.
Is that okay?
Yeah.
Okay, now moving on. So question 8 is done. Now haven't got into geometry application. Okay, it's time to start already. I have to skip all these questions. Let's focus on the question 13. Yes, this. So what happened over here is you have a L-shaped rod or something like that. Now in this L-shaped rod, they tell you that it is, or you think of it like a rig or something, huh? I don't know, some farmer equipment. Okay. It's an L-shaped rod, basically, this guy, PQR. It's leaning against a vertical wall, and that's the floor. So there's a 90 degrees here. Now, given that PQ equals 2 cm and QR equals to 8 cm, and the angle ORQ equals theta degrees, show that OR equals to 2 sine theta degrees plus 8 cos theta degrees. This is the type of question that will always come up in prelim papers or AMAX prelim papers. How do we deal with this? Your objective is to show OR equals to a certain length, right? So OR is at the base here, question mark. So it's really just a perimeter, right? Do we know anything about the length here? Okay, maybe that's not a good way to hint. I mean, let's start off by considering a bunch of dotted lines. So specifically, I can consider, let me see, this dotted line here. Can you see that dotted line? A perpendicular drop down from Q to the base OR. So that's a 90 degrees here, right? So we essentially split our OR up into two pieces, this length here and this length here, right? Here and here. Can you see that?
Yeah.
Let's just call this a point N, okay? The place where the dotted line lands on the OR. So that means that OR can be split into ON plus NR, right? Okay.
Okay.
Can you think of let's focus on NR first. Can you think of an expression for NR? What triangle do you see here?
Alright, go.
So maybe I just draw it in first. So it becomes super obvious. Right angle here, theta here, 8 cm here. So what's ON?
ON.
Oh, sorry, NR. What's NR? This is Q. Sorry.
NR is adjacent.
Exactly. So which ratio do you want to use? Picasso. Adjacent A.
8
The hypotenuse here.
uh-huh.
A and H.
Cosine
Exactly. Cosine theta equals to the adjacent NR divided by the hypotenuse 8. So therefore NR equals to 8 cosine theta. Okay. 50% of the work done already. You see that? 8 cosine theta here.
Okay.
Okay, maybe I should put a degree symbol here because they put a degree symbol there. Yeah, very extra. But okay, fine. Then we are done with NR, but how about ON? How do you find ON? That's when you have to involve 2. But then you see the answer, they need you to have 2 sine theta. So that means that definitely, I hope you can tell that ON reverse engineer, right? You need 2 sine theta, you're left with ON, so obviously ON is 2 sine theta, right?
Yeah.
But now you have to, but then let's just reverse engineer again. So ON over 2 equals sine theta, right? I'm cheating a little bit. I'm looking at the answer, then I work backwards. So you need sine theta to be, what was sine? Tuaka, so which one? So, right? O over H, opposite over hypotenuse. So this must be opposite, that must be hypotenuse in a right angled triangle. So let's just draw a right angled triangle. Let's just draw a right angled triangle. Then you need a theta here. Opposite is ON, hypotenuse is 2. I'm just looking at the answer and then I reverse engineer what I need. Can you go? Do you understand this logic?
Okay.
Technically you're supposed to start like this. Start with the right angled triangle from the diagram, but a bit too difficult. So I just start with the answer, then I reverse engineer, work backwards until I know my objective. So now all I need to do is to find a right angled triangle with an angle theta, hypotenuse 2, and a length ON. So where's that? Where's that angle? Where's that triangle? Can you draw? Can you see?
Like,
can you see where is that right angled triangle? It involves hypotenuse too, right? So can you draw it in? No, on the diagram here. Draw it in. Highlight the part of the triangle. The part that is the right angled triangle with hypotenuse 2. Okay, then the right angled triangle, where is it?
like,
it has to involve a length ON.
yeah.
ON.
Length
of ON. It doesn't have to be ON literally. It could be just the length of ON.
ON.
On top also a length ON. So where's the right angled triangle? Draw for me now. Draw the triangle. Yes, that's the triangle. This is the triangle. Okay? That's the key. But then there's a problem. Where's my theta? Where got theta in that triangle? I enlarge the diagram first. Where got theta? I don't see theta there. Where's theta? I don't see it. This triangle here, right angle. That's when you have to get very creative. Let me show you the procedure. Here is a right angled triangle, 90 degrees. So that means that this angle here must be what? 90 minus theta.
Minus theta.
Correct or not? You double check. Do they add up to 180? Yes, right?
Yeah.
Okay, good. 180 minus 90 minus theta gives you 90 minus theta. Okay, I showed the working. Minus theta equals to 90 minus theta. Okay, yes. So that is angle NQR. Angle NQR. Okay, so we are not done yet. We know that PQR is 90 degrees. Now this big angle is 90 degrees. We know this small angle here is 90 minus theta. So what's the remaining angle here? This is 90, that's 90 minus theta. What's the remaining angle here?
Theta.
Exactly, that's your theta. And then you can draw in the right angle triangle now. Here, right? Okay, let's label this, maybe I'll call this, I don't know, maybe I'll call this point F over here. Okay, so we can draw our updated right angled triangle. I should, okay, it's okay. This right angled triangle, okay, I should draw it a bit bigger. What is it? There's a point F, there's a point Q, there's a point P, there's a theta. What else we have? 2 cm is the length PQ here. What do we have? We want ON, which happens to be the same as PF, right? Because you can see this this rectangle here. Yes? Okay, good. So you agree that PF is the same as ON? Can?
Okay.
Equivalent to ON. Equivalent to ON in length. So now we are done now. We can always start off by looking at the diagram and get this right angled triangle, and then we conclude, I want ON, opposite hypotenuse. So I take the sine theta equals to ON over 2. So ON equals to 2 sine theta. Okay? Can?
Good.
Right, let's label this as 1. And then I'll label this as 2. Then a bit backwards, maybe I should label it 1 on top and 2 below. Then here I'll just write down OR equal, which is what we want, is equals to ON plus NR. And then we can just sub in 1 and 2. So we end up with 2 sine theta, okay, should be theta degrees, sorry, plus NR, which is 8 cos theta degrees. Then you just say sub 1 and 2. Okay? And then we're done. Shown. So you need a bit of geometry. Now, hence find, okay, that's shown already. Then hence find the value of theta for which OR is a maximum. So what do you do? And OR equals 6 cm. Part 1. Value of theta such that ST such that OR is max. OR is me. I'm max. I don't know. Okay, so what is OR? How do you find the maximum value of OR first? You see something times sine, something times cosine. I hope you can tell straight away this is what format. This is asking you to do what?
Formula.
Formula. Oh, that's the entire lesson for today. Of course, it's formula. What else could it be? Then yeah, so here I think you can just use, let this be equals to R times sine theta plus alpha. Okay, let's just work it out, expand it out, and what do we get? Sine A cosine B plus cosine A sine B. I'll leave you to verify that I am correct later. Then this one you can just expand it as R cos alpha sine theta plus R sine alpha cos theta. Okay, can sine theta here, cosine theta there? Yes? Good. So therefore we can conclude that R cos alpha equals to 2 and R sine alpha equals to 8. Yeah, so as a result, we get alpha equals to tangent inverse of what? Tangent inverse of sine over cosine, so 8 over 2. And we also get R to be equals to the square root of 2 square plus 8 square. Okay, so this one is 4 plus 64, which is square root 68. We can leave it as an exact value. Okay? Leave it as an exact value, square root 68. But this one, tangent inverse of 8 over 2, which is 4, no choice. It has to be an approximation. So let's just use a calculator. We get 1.3258 radians. Can? Good. So actually, by now, you should know what's the maximum value of OR, right? OR equals to square root 68 multiplied by the sine of theta plus alpha, in this case, 1.3258. So what is the maximum value of OR again?
6.
Huh? Say again. Repeat.
Wait.
Maximum value of OR. Maybe I heard wrongly. Sorry. Did you just say 6? It's not 6. It's square root 68. Can you see that? OR is this expression, which is R sine theta plus alpha. And we found out our R. It's square root 68. We found out our alpha, which is 1.3258. Alpha not very relevant, to be honest. OR equals to square root 68 times sine theta plus alpha. Then the maximum value must be a positive square root 68. This is the amplitude. Minimum will be negative square root 68. Okay, right? Sine is always in between +1 and -1. So if you times the square root 68 to each of them, it becomes positive square root 68, negative square root 68 as the maximum and minimum of OR. But this is not relevant. We focus on the maximum. Okay. Now, what's the theta that allows this maximum to occur? That's when you have to draw. You must really understand what's going on with the sine curve. So sine curve looks like this. This is, let's just assume this is a square root 68 sine theta graph. So maximum is positive square root 68, negative square root 68. When does the maximum occur? It occurs when the angle here is what the angle? Let's give radians. Let's work with radians. When does that maximum first occur? What's the corresponding angle?
90.
90 degrees, which is pi over 2 radians. Huh? Okay, can then that's not the graph that we're looking at. That's a plus 1.3258. So what do we do? Plus the graph move left or right? Think
what?
reverse psychology. Just now got the nerve, then he has to work harder.
Plus move to left.
So now got a boost, you have to work less hard. You can afford to be lazier. Lazier means you move to the
Left.
yes, left. So that also means your pi over 2 will also move to the left. So does it become bigger or smaller when you move to the left? Smaller, right?
Yeah.
Left is more negative, right is positive big. So if it's smaller, do you plus or minus pi over 2? Or minus? Smaller, right? Smaller, so?
Minus.
Minus how much? Here, the lucky for you is just a 1 theta. Don't need to stress out about how much harder the theta is to work. Theta is on its own. He doesn't have a boost, 4 times boost or anything. So when there's a plus 1.3258, he can afford to be lazy by 1.3258. So it's minus 1.3258. Okay? Clear? Hopefully. Minus away 1.3258 from the pi over 2, and you get 0.24497. Approximately 245 radians. Okay? Can I hope the screen wasn't blocked. Just now there was some notification. Yeah, so that is for part 1. Not done yet, still got part 2. Let's go to part 2. Part 2. Find the value of theta for which OR equals to 6 cm. This guy. Value of theta for which OR equals 6 cm. How? So that's when you need to
Six.
Exactly.
OR
formula
equals 6.
equals to 6. Exactly. And then you solve for theta. Can I leave that to you to do on your own?
Okay.
Solve for theta. Yeah, that's easy. Okay, I think the most difficult part, honestly, is to identify the right angle triangle. Okay, Ken? Now, since we're talking about right angle triangles, let's just do, can I just go through with you the reason for why the sine A plus B formula works the way it is?
Okay.
I'll give you the proof for it. Let's go to the notes. Okay, so this one should be all the way at the bottom, extra. Since we are starting to talk about the R formula and using the geometry already, y sine A plus B equals to sine A cosine B plus cosine A sine B. I hope you are it's clear to you now that this is really just a proof. I hope it's clear to you by now that sine of A plus B is definitely not the same as sine A plus sine B, right? Not that simple, huh? You need to multiply by those extra things. But why is it true? So let's think about it. What is the sine of A plus B? It's really just asking you to start with a right angled triangle, right? And then, okay, maybe I'll just, okay, yeah, I'll just continue. We are starting with a right angled triangle, and then we want you to take the opposite over the hypotenuse, right? That's precisely what sine is asking you to do. It's asking you to take the opposite over hypotenuse. So let's just say we start off with angle A over here. Not A plus B, just A first. Then we have a right angled triangle like this. And then on top, on this hypotenuse of this right angled triangle here, I'm going to construct another right angled triangle. Oh, that's not good. Like this roughly. Does it look 90 degrees, this one?
Okay.
Like 90 degrees over here.
Yeah.
Roughly. Okay. Can, good. Then what we're gonna do is we're gonna drop this thing called the perpendicular down the bottom like this. Let me just drop a perpendicular down like this. Okay, and we're gonna drop another perpendicular down across like this. Can you see? So 90 degrees here, 90 degrees here. Okay, and also this angle here, I'll call it B. Also, without loss of generality, this length here, I will call it length 1. Okay, meaning that even if I didn't work with 1, I use other. I mean, if I want to generalize it to like, let's say 1.1, 1.2, 1.3, the argument I'm about to give will still work. I will still be able to show that sine A plus B equals sine A cos B plus cos A sine B. Okay, so before that, let's just label some points first. Let's call this point A, B, C, D, E, and point F. Can you see the points?
Okay.
Can Okay, so now let's figure out what is the sine of A. What is the cosine of A? What is the sine of B? What is the cosine of B? Now, Picasso tells you what? So, right? Sine. So you must focus on a right angled triangle, sine A, opposite over hypotenuse. Do you agree that it's just CD over AD?
CD over AD. Yeah.
Correct, right? Opposite over hypotenuse. How about cosine A?
Cosine A will just be AC over AD.
How about sine B?
Sine B will just be ED over
AE. But it's just a 1.
1.
So ED over 1, which is just ED. How about cosine B?
BD over 1.
Huh? BD?
Wait.
Cosine B.
I mean.
Triangle. You mean AD, right?
Yeah,
Jason?
I mean AD.
AD over 1, which is just AD. Okay, good. Then now let's consider what is okay, let's do a bit of a trick here. It's called angle chasing. Angle chasing. I'm gonna chase for an angle. If this here is angle A, right? This here is 90 degrees. What is the angle over here? Oh, maybe I don't use
90 minus A.
90 minus A. Here is a 90 degrees, right? Can you see a rectangle here? Right? So what's the angle over here? Sorry, I should label A here. So what's the angle over here? Must add up to 90. It's just A, right? Exactly. A plus 90 minus A adds up to 90. Then here we also see that there is a right angle triangle there. So that means that, okay, actually here will be 90 minus A, but not very relevant. More relevant would be this angle here. I purposely constructed this second triangle to be 90. Exactly, yes, 90 minus A. Good. And also, here is a 90 degrees, right? Can you see the 90?
Yeah.
So there's a 90 minus A. Sum of angles in a triangle add up to 180. 90 minus A, what's the remaining angle?
A.
Exactly, it's A. Very good. Okay, I should be using capital A. Okay, good. So that means that I now currently have a length A here. I mean angle A here. This will be relevant to us because you can see a right angled triangle here, right? So that means your sine A and cosine A, there's another way to express it. Focusing on triangle EFD, this is focusing on triangle ACD and triangle ACD. But there is another way to find out the sine A and cosine A where with reference to the second triangle being triangle EFD. Can you tell me what's the ratio this time if it's triangle EFD? If we focus on triangle EFD, cos A, sine A is
FD over ED, which is
very good.
Oh, okay. Yeah, then EF over ED.
And EF over ED. Okay, and yes, it's not 1, but rather I think you see it already. ED. ED is sine B. Do you see that?
So
So that means that we can now, I need more space. Hold on a second. We can now replace this FD, okay, FD leave alone, but the ED we can replace with sine B, right?
Mm.
And that also means that sine A is still on the left-hand side, right? Which implies that sine A, oh, yeah, am I going in the wrong direction? Yeah, I think I'm going in the wrong direction. Sorry. Let me think a bit. No. Okay, I don't want to work with this one. Okay, fine. Okay. Sine A, sine B equals to FD. This is not relevant to proving this particular formula. It's proving the cosine A minus B formula. This one not relevant. Let's focus on this fella instead. Cosine A is still cosine A on the left-hand side, but EF over ED. Let's leave EF alone. But what is ED? ED in this case is sine B, right?
Yeah.
Remember, ED is sine B. So you can
Yeah.
replace with sine B. Are you confused? I hope not.
No.
No, then therefore EF is equal to what? Cos A sine B, right? A cos A sine B, right over here. That's interesting. Don't you think so?
Okay.
Oh, we're getting somewhere. So let's just pause a while. We are dealing with all the details here. EF equal cos A sine B, but what's really our end goal is to show sine A plus B equal to this guy, right? But what is sine of A plus B? It's really just asking you to use Stochastic, right? In a right angled triangle. And where is A plus B? It's this huge angle here, right?
Uh-huh.
The yellow one. So can you
Uh-huh.
see a right angled triangle involving A plus B? What triangle is that? Triangle? What? I didn't draw the right angle. It should be here. So what triangle?
AEB.
Triangle AEB. Okay, so we focus on triangle AEB. What's a sine? Opposite over hypotenuse, right? So what over what?
EB over AE.
Very good. EB over AE, and AE is just 1, right? So it's EB over 1, which is just EB. Then that's when you have to be creative. EB is this part, right? Do you agree that I can split it up like this? EB is really just this part and that part. EF plus ED.
Yeah.
Okay,
Yeah.
we're getting warmer, almost there. So EF, we got cos A sine B. Right? Do you see that?
Mm-hmm.
So we can just substitute in. Okay, good. So we can now replace EF with whatever we found over here. Number 1, cos A sine B. This is because of 1. Okay, then now we still got DC. So of course the DC must be the second half, which is second half of the formula sine A cos B. So how can we recover our sine A cos B? This is when you have to think a little bit. How?
DC.
I wonder if I did anything wrongly. We need CD. We need CD. But maybe I think it's easier if I write it as CD. So that it's more obvious. Where have I seen CD before?
Sine A.
Sine A over here, right? Okay,
Uh-huh.
maybe I'll just call this equation star. Okay, a bit messy, but from star we can deduce that CD is equals to AD times sine A, right? Do you agree? Cross multiply. Very good. So what is AD? Look carefully at the sea of information.
Cosine
AD?
B.
AD is cosine B. Over here, right? Let's just call it double star. So this by, okay, here's how you can present it. Put an equal sign here, then put a super long equal sign here, then on top I draw a double star to say that I am using the double star information, simply replacing the AD with cosine B, sine A. And there we go. CD equals to cosine B sine A. Do you see that? Then I will label this information as happy face. Okay, happy face. And then I can strike this off, CD over here. CD equals to cosine B sine A, replace with happy face. And then I will get my formula, cos B sine A. This is happy face. Okay. Therefore, that's how we deduce the formula. Oh, this was written thousands of years ago. This proof in a different language, in Greek, in Euclid's Elements. If you're interested, you can go and read. It's very thick. Yeah. So that is how you get the formula. It is not the same as sine A plus sine B. Okay. You can use the similar diagram, like to deduce other identities like sine A sine B equals to FD. Then you must think about how to construct the other angles. So, like for example, cosine A plus B. What will cosine A plus B be? Adjacent over hypotenuse, right? So it will be AB over 1, right? Okay, maybe I'll just give you a hint, exercise for you if you're interested. Cosine A plus B will be adjacent AB over hypotenuse AE, which is AB over 1, which is just AB. But AB is short. If only it could be a bit longer, like AC. And that would be nice. In fact, it is. It's just AC minus BC. Okay? AC minus BC. Do you agree?
Mm-hmm.
Then if you know, and that's when you have to use the C of identities that we have found out. You see AC here? You can use the C of identity. You see AC, you see AD, right? Then you can go and figure out what is AC and what is BC. Substitute in accordingly, and you will be able to get your answer. Okay, maybe one more hint for you is BC and FD. What do you notice? What shape is this?
Rectangle.
Rectangle. So opposite sides of rectangle, same length, right? So BC and FD are really just the same, which means you can replace this BC with FD. So it's really just AC minus FD. Okay. Then from there, you should be able to solve already. What is AC? What is FD? Then you will be able to get your cos A, cos B minus sine A, sine B. You should go through this exercise. Try and substitute in. Okay, that's all. Then yeah, going through this exercise where you go and construct the sine and the cosine in terms of a right angle triangle will help you in your R formula questions, like especially this kind of questions. It can help you to see the hidden right angle triangle. Okay, these kind of questions are really just inspired by that proof. These kind of questions are inspired by that proof, which was written thousands of years ago. The trick here is to drop a dotted line and then you can do some angle tracing to figure out where's your angle theta. All right, good. Do I have time? Okay, it's already 11. Okay, I didn't have time to go through the advanced questions. Would you like extra homework? Want to try the advanced ones? Just 1, 2, 3, 4, 5, 6 more.
Okay.
Cannot. Then you just try those. And we'll go.
What if I cannot do?
Then we'll go through next week.
I.
Okay. Okay, then that's all for today. Okay, question 14 to question 19 of the other of this worksheet as well. I'll add it into the list. Can? Okay. Bye-bye.
Thank you.
There's a summary at the back as well if you want. Yeah. Okay, bye.
Sorry. Bye. Thank you.
Thank you.